Okay, so we're going to look at another example of graphing between positions, velocities, and accelerations. And we're going to follow a different story. The story we're going to follow this time is that you are heading to work at the MSC from your dorm on North Campus. You have a very special skateboard that instantly has you moving at 3 meters per second as soon as you get on. Just go with me on that for a moment. It accelerates you to a maximum speed, so it speeds you up, where you cruise to the MSC for a little bit. Sadly, there's no place to lock your special skateboard and you can't take it in. So you have to continue south past the MSC, still at that steady maximum speed, to where you finally find a spot. So you slow down as you approach the spot, coming to rest. You're late for work now, so you start running back to the MSC, which is now north of you, speeding up at a steady rate the whole way there. All right, so let's look at how we might graph that story on a position time graph, velocity time graph, and acceleration time graph. So I'm going to share my screen with you that allows us to look at the development of that story as we graph it. All right, so I have position, velocity, and acceleration here. So where do we begin? All right, so let's start with the velocity. That's the one I tend to choose. It makes it a little more easy for me to wrap my head around when I use the velocity versus time graph. So it tells me that I live on North Campus and I'm going to head to the MSC, which is south of me. So I know that at least at the beginning of this motion, I am going to be moving in the southward direction or the negative direction. So my velocity is going to be on the negative side of the graph. All right. It tells me that I already am moving as soon as my time starts. So that's that special board that has you instantly moving at 3 meters per second. So I have an initial velocity moving in the southward direction. So I am not at the 0 velocity mark on my graph. I have some level of velocity when I start. It then tells me I speed up to a maximum speed. It says I accelerate to a maximum speed, but I know that means speed up in this case because I would be going to a maximum speed, which would have to be larger than the speed I started at. So I'm speeding up. Now, if I'm speeding up, that means my velocity numbers are getting bigger and bigger and bigger, and bigger numbers on a velocity time graph, and the negative axis is going to go downward. So I speed up at a steady rate, it says. I'll do 2 X's there. And then it says I continue at that maximum speed until I get to the MSC. So we'll go another 2 of these squares. But there's no place to park. So I have to go past the MSC. I'm still heading south. I'll go another 2 blocks. And I then slow down as I approach the spot. So my velocity numbers must be getting smaller as I approach the spot. And I approach that spot and come to rest. So my velocity numbers are getting smaller, and all the way to 0 velocity, I come to rest. I have to lock up my bike, so that's going to take me a little bit of time. And then I'm really late for work. So I got to run back to the MSC, really late for work. Fortunately, I can run a lot faster than I can cruise on my skateboard. Well, now the MSC is north of me, so my motion is going to be in the positive direction. And I just added in that little, we're going to go faster and faster and faster at a pretty quick lick at a steady pace. So now I am moving in the positive direction and I'm getting faster and faster and faster. So my numbers have to go up and up and up. And so we'll just say we get to here super fast. Probably not the most realistic motion, but we'll go with it for today. At which point I go all the way there, and then I'm no longer interested. I probably come to a stop, so that would look different, but I just care about me speeding up all the way to the MSC, and then my motion is done for my analysis. All right, so we have motion now on both sides of the axis in velocity because we're moving in both directions. To begin with, we're moving from North Campus south. So we're moving in the south direction or negative velocities. I go past the MSC and then I start moving in the north direction. So my velocities must have switched sides of the axis. All right, well, how does my position and acceleration compare? Well, for those first two time blocks, it says that my position is getting faster and faster and faster. Now the question is, where do I set my origin? Where do I start? How do I know where in the world I am? What does it mean to be at my dorm? What does it mean to be moving in another direction? Well, let's call the MSC the origin. So I'm going to place the origin here at the MSC. You get to define that. And remember, on a position versus time graph, the shape should be the same for all motion, but depending on where you define that origin is where that shape appears on the axis. So I'm going to define that the MSC is the origin, which means I'm starting north of the MSC at my dorm. So I'll say this is the location of my dorm. All right. So during that first couple bits of time, I am heading towards the MSC. I haven't gotten there yet, but I'm heading towards the MSC. Now, as I move, so I'm going to head in the negative direction. My slopes then must be negative. Now, I'm going to remind myself where I actually end up at the MSC. And we want to keep in mind that the MSC is where we end up at the very end of our motion. So we know that we're going to end up at the MSC at the very end of our motion. So my position at the end of the motion is going to have to be at the MSC. But we also know that there's a point where we go past the MSC while we're moving at that steady rate, remember? So somewhere in here, I'm moving past the MSC. So somewhere during this steady rate, I'm also going to be at the location of the MSC. So there's no specifics in this story. It's just general shapes that we're worrying about. So we can define that. Let's just define it right in the middle of that motion. Let's see. So I know I'm going to hit the MSC somewhere during this constant motion, and I'm just going to put it at the middle. So that gives me a framework of how my behavior should be during these specific locations. Now, sometimes, and I like to do this, it helps to sort of chunk out the motion. So this is just another strategy. So I'm going to just put some dashed lines in here. So during this time, I know I'm speeding up. During this next time, I know I'm going at a steady rate and I'm going to hit the MSC's location. I'm then going to continue at that steady rate and drive by the MSC. So that's sort of a continuation of that steady rate. And then during this chunk of time, I am slowing down to my parking spot. I then am taking time to park during this chunk of time. And then I am racing my little butt back to the MSC because I'm already late for work. So you can see I've kind of sort of chunked the story out to help guide my drawing. All right, so for this first chunk, I'm going from the dorm and I'm speeding up in the negative direction. So my position is getting bigger and bigger and bigger as I speed up. My slope's negative because I'm moving in the leftward direction. So I'm going to curve in the downward direction as I draw my position. So does this curve make sense? Well, for every little bit of time, I'm getting more and more positional change. That's a good thing. That means I'm speeding up. The slope of this curve is negative. That negative slope indicates that the direction is in the negative direction of the motion. So I'm heading from my dorm on North Campus down towards the MSC. So I have a negative slope, negative velocity, and that slope is increasing as represented in the velocity. So I should look good. I then am at a steady rate for a little bit to the MSC. I said this is the point that I cross the MSC. So then I travel at a steady rate to the MSC. I continue at that rate past the MSC for the same amount of time, so I'm going to actually cover the same amount of distance in that time. And all of that is done at a nice, steady slope. A negative slope because I'm still moving in the south direction. Over this next chunk of time, I have to slow to my parking spot, which I see just up ahead. And so I'm still moving in the southward direction so that my slope should still be negative as I curve, as it changes, but it should be getting shallower and shallower and shallower because my velocity is getting smaller and smaller and smaller. So I'm going to notice a curve that makes the slope shallower and shallower and shallower. Still in the negative direction, but it's slowly getting shallower. Smaller, smaller velocity. My numbers are going down. I then stop. And on a position time graph, that means I stay at a location for a little bit. So my position is not changing, horizontal line on a position time graph. Then I have to get my butt to the MSC. And so I'm going to speed up all the way to the MSC. I'm moving to the north now, so my slope of my position time graph needs to be positive. It needs to be getting larger and larger, so steeper and steeper and steeper. I need to be acquiring more position for every tiny little bit of time. And my slope moves like that. So now my slope is positive, and it's getting steeper and steeper and steeper. The velocity is getting larger and larger and larger, all the way to the point I get to the MSC. And then I don't care anymore what I do after that. As soon as I got to that location, the motion I cared about was over. So we have a curve in the negative direction representing that we are speeding up and moving to the left. We then are moving at a constant velocity to the left past what I've defined as the origin. Continue on that constant velocity till we see that parking spot up ahead. We then have to slow, continuing to move in that negative direction, the southward direction, but I'm slowing down, so I'm acquiring less position in any given amount of time. My slope is becoming shallower. I then hang out, lock my cool skateboard up, so my position doesn't change, and then I hightail it, speeding up the whole way back north, positive direction, and I get to the MSC as I speed up. All right, so on the acceleration versus time graph, well, I'm speeding up to begin with, and I'm doing that in the negative direction. I am moving in the negative direction, speeding up, acceleration has to be the same, negative. Negative slope, acceleration is negative. I then go at a steady pace, so I have no acceleration, and that continues past the MSC. I then have to slow down to my spot. Well, I'm moving south, negative, but I'm slowing down, so my acceleration and velocity are in the opposite direction. So if I'm moving south, my acceleration must be to the north. And it's a little bigger. This is a little steeper than that one, so I'm going to make it a little taller than I went down. I then come to a stop, no acceleration, and then I'm hightailing it back to the MSC. So I'm moving in the north direction and I'm speeding up. Acceleration and velocity must be in the same direction, giving rise to speeding up. And I'm going really high acceleration because I have to get to that MSC. And I don't know where I am after that. Doesn't matter. No longer care about the motion. So while our acceleration graph will match our velocity graph in the direction of the slope. Negative slope, negative acceleration. No slope, no acceleration. Positive slope, positive acceleration. No slope, no acceleration. Positive slope, positive acceleration. We want to look just at the acceleration as from the perspective of the rate of change or the slope of the velocity graph. Or we can talk about it in terms of what direction are we moving? Are we speeding up or slowing down? And that, of course, gives rise to the acceleration. Moving again, thinking about the position graph, I had set the MSC at the origin. If I had set my dorm at the origin, we would imagine this entire graph just shifting down. The motion remained the same, but now the MSC is some here south of the origin, and my dorm is at the 0 point. So this whole graph would simply shift down. If we set the origin at my parking spot, well, that would also then shift the graph and would shift it a little left, since the parking spot is even further south of the dorm of my dorm than the MSC. So the shape doesn't change, but depending on where we define the origin, it shifts along that axis. All right, so a really intense example looking at motion crossing the axis, looking at velocities changing from positive to negative and how that might look. And then always starting with that velocity, I think really is helpful. And then developing how the position time graph looks based on that change in velocity, and how the velocity, or excuse me, the acceleration time graph looks based on the slope of that velocity time graph. All right, so look in between those three types of graphs with some complicated motion. Good job.